Hey everybody, this is Mr. Munson, and Unit 6, Similar Figures. We're continuing here with concept number 2, 6.2, Similar Figures and their relationships. And so if you take a look at these two pictures, it's a father and son and a mom and a daughter. And so these are not congruent shapes or figures, but similar. Obviously a dad cannot be congruent to his son, and a mom can't be congruent to her daughter, but they can be similar, and these are striking how similar they are. So let's go ahead and get started. All right, so looking at 6.2 similar figures, you might throw your date up at the top, but looking at these two figures, the green one and the red one, I would want to identify if these are similar figures. First of all, they're both hexagons, so I can progress. If one was a triangle and one was a hexagon, I don't need to go on any further. They're not similar. So I count the sides and I see that they're both hexagons. Now I'm going to confirm through the definition of similar polygons that these things are in fact similar. So for the figures to be similar, corresponding angles must be congruent. That means for every angle in the left figure, there has to be an angle that matches it, and it has to be in the same place. So take a look at angle A, and it matches G. So far we've got one set of angles. Now I'm going to systematically just go clockwise, make sure that it follows the same order. So if I go to B in the left, I'll see that it's double struck, and sure enough, H, the next one after G, clockwise, is double struck. And I just follow along, and sure enough, every angle matches up. So far, we have half of the definition of similar figures completed. We have the angles are congruent. Now, let's check the sides are proportional. What that means is I would go up and I'd grab the sides lengths, so it was like the length between A and B, and I would take that length and I would find its corresponding side over in the right-hand figure and write a ratio between them. And once I wrote that ratio, I'd start writing the ratios between all the other corresponding and then checking to see if those ratios are identical. Now they might look different, like 1/2 looks different than 5/10. But when you take 5/10 and reduce it, it goes back into a 1/2 kind of relationship. So the fractions might at first look different, but once reduced, they're the same. Okay? So if we go through and we write a ratio between AB over GH, I'm going to check to see if that is equal to the next set of corresponding sides, BC in the left, and see if it's the same as HI. Now notice BC is between the double struck and the three struck angle. If you take a look at that, and then go over to the red one, and between the double struck and the triple struck angle is HI. And so we just continue to write these ratios and we check to see if they're the same. Again, they don't have to look the same, but they can reduce down to be the same. And if that happens, if I find that all those ratios equal each other, then, let me grab that triangle, there we go. If I find that all those ratios are in fact the same, equivalent, then I've completed my definition of similar polygons and they are similar. If I find one ratio that is not the same as the others, then the figures are not similar. So while we're looking at a thing called a scale factor, if you look back at your vocabulary, you just see a scale factor as a ratio between any two corresponding sides. And it pretty much tells you if this figure is getting bigger or smaller. And so in this case, the scale factor, I could write a ratio between any two corresponding sides. So if you look, AB corresponds to EF. I'm going to confirm that in my given similarity statement before I just kind of look at the figure and make that assumption. So scale factor of this figure could be 4/5. Okay? And that just represents a ratio between any two corresponding sides. So now if I wrote the ratio 6/2x, that is a scale factor, but it has an unknown x in it. Okay? Okay, so let's take a look at this next problem. This next problem is looking at two shapes, and the question down below says, is there enough information to determine if the figures are similar? And so what we would do is we want to remember that there's basically three main ideas to determine if shapes are similar. The first one is the very basic. Do the shapes have the same number of sides? So that's definitely the case. They're both five-sided figures. So I can continue on and determine that that's possible. Or not possible, but true. Okay. The next thing, let's look and see if for every angle on the left matches an angle on the right. So if I come up here to A, I see that that's a single struck angle. And if we come over here to G, there's a single struck angle. So there's a match there. Okay. So I'm just going to kind of go around. There's a two strike, and right next door is two strike. Now this is really important. This two strike couldn't just be anywhere. It has to be a neighbor to the single strike. Now it happens to be to the left here. It could have been to the right. But if it ends up being the right, then the rest of the angles have to continue around in the same order. Okay? So I've got that double, double. I've got this triple, triple. And it's just following itself around. One's clockwise and the other one's clockwise. So it's just following the same path. No big deal. Okay? So we're back to that. So we know that the angles have matching angles. So that's good. Now the next thing is sides are proportional. Now I have a check mark next to that, but let's take a look. Sides are proportional means that I can write a ratio, or I should be able to write a ratio between any two corresponding sides, and that ratio, that fraction, should be equal to whatever the other corresponding ratios are. So here's AB. It's between the single struck and the double struck angle, and it's a 7. So I'm going to go over here and find the side that's between the single struck and double struck, and there's a Y. So it's actually unknown. So that immediately tells me there's not enough information in this problem to tell me if it's similar or not. I can't go and find why. I'm done. There's just not enough information for me to determine if they are similar. To do that, I'd have to write a ratio between every set of sides, and there's just not enough information. That's not the only side missing. That one's missing. And of course, this Z right here is missing in this one. So I can't write all the ratios, which I would need to, and then verify them that they're all the same. Since that's not possible, we would determine this is not possible. Okay, there's just not enough information. Okay, so let's say instead of that, instead of having to draw a whole new problem, we're just going to reuse this problem. And suppose I came into this problem and said, hey, these two sides, or these two figures are similar, right? So as an instructor, I gave that to you as a given. I said, hey, listen, since these two figures are similar, write a similarity statement. So what you'd have to do is start looking for some information to allow you to do that. So here I am with an angle A, with a single struck angle, and this one, angle G with a single struck. This is what I know. A, B, C, D, E. Remember, we always follow the alphabetical order in the first one. And then we come over here and we'll write down G, because A and G correspond to each other. Double struck, B, corresponds with H. So we'll write that one in. And we're just going to continue this path around. I, L, K. Cool. So given that the shapes are similar, I was able to write a similarity statement. However, without all the information, I couldn't come up with it on my own as a student or a worker on this problem that they are similar. But here we are. We know that they're similar because I said they were. We got similarity statements. So there are some other questions that we can ask. How about a scale factor? See, we don't need to know all the sides to come up with scale factor. All we have to do is come up with one side in the left that matches one side in the right, and write the ratio between them to get a scale factor. So what I do is I just start looking. Here's a 7, and it corresponds to AB. So right there's 7, AB. So it corresponds to GH over here, and it's a Y. So I don't have that to write a scale factor. Okay. How about the 9? The 9 goes with the X here. Again, that's unknown because it's between the same set of angles, and we're looking at the similarity statement to verify it. Here's a 5 on ED. Now ED, which is the same as DE, corresponds to LK. So let's go find LK. And LK is LK is 22.5. So I write a ratio between those, and that represents my scale factor. Now we're not allowed to have decimals in the denominator, so I will use my calculator to find out what the scale factor is. So I come up with a scale factor of 2 over 9. Okay, so just basically I use my fraction key there on my calculator to simplify that. Okay, fantastic. So we have 2/9. That's the scale factor. So any ratio that I write between the corresponding sides has to be 2/9. So remember that 2/9 is just a simpler version of writing 5 over 22.5. Now I could have use 5 over 22.5, but I like 2/9. And so what I'm going to do is I'm going to use that scale factor, that ratio between any two corresponding sides to start solving for x, y, and z. So let's take a look at x. Okay, x, if you take a look at x is related to hi, and hi is these two letters, and that corresponds to BC. So we'll go to BC, which is 9. So let's do 9 over x, that's the two corresponding sides, should be equal to 2 over 9. Cross multiply, and I end up with finally finding my 40.5. Let's do another. So y is h between hg, so I'll go up here to hg, this is the first two letters. That side corresponds with ab. Okay, so let's go AB. So 7 is to Y, 7 is to Y, and then that ratio between those two sides should equal the scale factor, right? Which was derived by the other two sides. Cross multiply. Okay, great. So now what I want you to do is go ahead and set up the proportion for finding Z the exact same way. If you're not sure how to do Z, then you should back up and watch me do X again and Y again and make sure that you understand those steps. All right, put me on pause and find Z. All right, Z is to 45 as 2 is 9. Remember, the 2 over 9 came from grabbing a side from the left and putting it over to the right. So when I go to write any other ratio between sides, I always want to grab from the left and put it over to the right. And when I cross multiply, I find Z is 10. All right, a lot of good stuff there. If you didn't follow that, just back it up and rewatch that. Okay, let's do two things real quick on this one. Find x, and then the ratio between the perimeters. Remember, the perimeters is the distance all the way around. Finding x, quit it, pretty easy. So what I'm going to do, I'm given the similarity statement down here, so I just need to correlate two sides. So let's look at AB, which goes with FD. Hopefully there's that side, so there is. So I'll say 5 is to 10, and that represents the scale factor, and we know that could be 1/2. Now, I could also just stop, not even worry about reducing it, and just say, hey, that's going to be equal to x, so I chose from the left, and then AC. AC is the first and the last, so it goes to FE, 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 which is 8. Now I'm going to solve. So that side is 4, no problem. See, and I needed to find that first so that I could find the perimeter, okay? All right, so I just added up the perimeters, and I found the perimeter to the left is 12, and the perimeter to the right is 24. Now, if I was going to write a perimeter ratio, I just write left over right, just like I did my other ratios, and I do 12 over 24. Now, this is the big idea. That reduces down to 1/2. If you look closely, the scale factor, which is any two corresponding sides, in this case, I did 5 over 10. It's 1/2. So this is what we find out. Here's the big idea. The scale factor, in this case, it was 5 over 10, which reduced to 1/2. The scale factor and the perimeter ratios are the same. Let me change that grammatically. Are the same. Okay? That's very important. Write that down, highlight it, whatever you have to do. Now, if you look at our student learning map, you'll see I can determine the scale factor between two figures. We did that in this video. I can determine if polygons are similar using the definition of similarity. So you check make sure the number of sides is correct. Make sure each set of angles has a matching angle. Make sure the sides are proportionate, right? I can write similarity statements given a diagram. We did that. I can mark a diagram even in similarity. Now we did partially that, but it really hasn't been done yet. We have that idea. You would have to do it in practice, and that's where we'll do it in class. I can solve for missing measures in similar polygons using ratios and proportions. We did that just now. And I can apply the rules of similarities, parameters, and similar figures. And again, we just did that. Okay? All right. Take a few seconds, just write a quick summary. Sometimes it's helpful to use your I can statements to help you write that. But after that, draw your line for the next time, and let's go ahead and pull out another piece of paper and start doing our problem. Okay, so I'll zoom in so you can see this a little better. Just know that I deleted problem number 2, so it's going to go 1, 3, and so on. Okay, let me zoom in so you can see it. I'll scroll through these. Don't forget to put your title at the top. Right now, go ahead and put your name, date, and period at the top, so you're not trying to do that in a rush as I'm having you pull it out, okay? So let's go through. Here's problem number 3. 4. And then there is the last problem, which is the circles. Now let's just go back to problem number 4 real quick. Let me just give you an idea. Remember, the perimeter ratios are equal to each other. So this is an unknown over here, this perimeter of this one. This is the unknown. And so you should be able to set up a proportion and solve for that unknown perimeter, even though you don't have all the sides in the figure to the right. Okay? And then last thing on this last one, again, good review problem. Go back, pull out go back and pull out your formula sheet and see if you can find out which formula you should be using on it. All right, you made it. Let's close this up. Bring in those problems to class next time.